Good day to all of you. Now we come into the examples in univariate analysis, the ANOVA. This is first from the series that we will have examples in univariate analysis. The ANOVA stands for the analysis of variance. Now in 2003, Real Foods, a mango juice manufacturer, had a predominant market presence in South India. Now they had this enjoy bottled mango juice, and they had ventured into another product, an orange juice concentrate. The market was already full of canned and bottled orange juices, so they opted for the concentrate form, which was new, targeting the home consumption segment. So now uh, they had to find out how exactly they went about promoting this particular orange juice concentrate. Now, one thing that we must notice is that they believe that powder concentrate was much more convenient than the canned and bottled orange juices. Second is the belief that the quality of juice made out of the concentrate was better because unlike canned juices, the juice from the concentrate could be prepared just before consumption. Another very important feature was that the powder concentrate was available at a much lower price. Now the marketing manager was in a dilemma how to advertise his new product. To facilitate the decision, he conducted an experiment in 3 cities. In Bangalore, the marketing manager launched the new product backed by advertising, uh, stressing the convenience of the product. The product was easy to carry from store to home. The product did not require storage and did not have uh, the fear of spoilage without a refrigerator. In Chennai, the advertisements emphasized the quality of the product, the freshness proposition, and in Hyderabad, the price advantage was advertised. Data of sales for 20 weeks was collected from all 3 cities. Let's have a look at the data. Here, if you see, the null hypothesis is that the variance in sales in the 3 cities is not because of the difference in communication strategies. So what exactly is ANOVA? Before we go into the details, ANOVA is the analysis of variance. Here, there are 3 samples, and each sample will have a variance within the data itself. That is the variance within the data. Okay, giving us the first is estimate of the population. Secondly, we have 3 samples will give us the variance between the 3 samples, giving us an idea that of the variance that is originating from the difference in the 3 samples. So that is another estimate of the population variance. This is a typical one-way ANOVA data. If you really see, you can have 3 samples of 3 different sizes, and your sizes can be N1, N2 and N3. Now, each sample size here is 20 only. So all N1, N2, N3 are all 20. You got sample means of 70.3, 62 and 62.95. Secondly, you have degrees of freedom. There are 2 types of degrees of freedom. Between samples, which will be K is your number of samples. So K minus 1 is degrees of freedom between. Another is degrees of freedom within, that is n minus k, that is 57. So it is 60 minus 3, that is 57. The grand mean is the mean of the means taken together. Now, one estimate of population variance comes from the variance within the sample. How is that calculated? The computations are shown here. If you really see, variance of the ith sample will be sigma xi minus xi bar square divided by n minus 1. That will be your SI square. So if you want the sum of squares within the samples, that is computed by taking sigma I, again sigma xi minus xi bar whole square. Mean ms within is computed by finding out SS within divided by DF within. Here you can see SS within is 5399.15 and MS within is 5399.15 divided by degrees of freedom within, that is 57. It will make 94.7. Second population variance comes from the sample means. MS between. SS between is sigma Ni x bar minus x bar bar whole square. And MS between is equal to SS between divided by degrees of freedom between. Now MS between is 825.43 divided by 2. So it is 412.72. If you now see the computation of MS between. Computed F ratio would be MS between divided by MS within. In this particular case, it is 4.36, which exceeds 3.15, which is the critical F. Critical F is got from the table with two particular degrees of freedom. In this particular case, it will be 2 and 57, and that alpha is equal to 0.05. Thus, variance on sales could depend on the communication adopted. The graph is given here.